Alright, in this video we're going to go through a lot of our major definitions for experiments. We'll go through a couple examples, and then we'll leave the rest of it for later. So first, quick review. Observational study versus experiment. We talked about this back at the beginning of the chapter. An observational study observes and measures, but does not attempt to influence the responses in any way. So this is, we think of most surveys, samples, we ask. In an experiment, we deliberately impose, we tell. So this is asking someone what they did versus telling them what to do. And you can add that in as well. So it deliberately imposes some treatment. This doesn't have to be medical. This can be anything that we ask the individual to do, and then we measure their responses. So this is ask, and this is tell. The response variables, the explanatory variables, can be the same in either way. It comes down to, did these subjects get to choose what they were going to do, or were they told what to do? And this is important because only an experiment can establish cause and effect. And this distinction between observational study and experiment is huge. So cause and effect, is this a relationship that we saw, or is this something where we know that the explanatory variable caused the effect that we saw? And so because of this, knowing whether we're talking about an observational study or experiment is extremely important because of this cause and effect. That's going to come back over and over again as we go through not just Chapter 3, but the entire course. So we want to talk about what are the pieces, what are the vocab that we need for experiments. So first, what are the pieces? Three major things here. So an experiment, statistical study, where we actually do something. We impose a treatment. And then we do that to peoples, animals, objects, experimental units, or subjects. And then we observe the response variable. So what are the pieces we need to identify anytime we're doing an experiment? Treatment. Again, this is beyond just a medical treatment. This is any specific condition we apply to individuals. It could be a study method. It could be a diet. It could be a medical treatment. Whatever it happens to be. It could be the type of shoes that someone's wearing. This is the treatment, and it's specific. What different treatments do we have? Do we have two different types of shoes that our subjects are going to wear? Those are our treatments. Our experimental units are the individuals in the experiment. Sometimes they're called subjects, but experimental units. So we know whoever's participating in this experiment, whether they're people or animals or just objects. And then when they're humans, it's a lot nicer to call them subjects rather than experimental units. So let's do an example here. We're going to design an experiment to see if sleep affects test grades. So that's our explanatory and our response. We're going to measure sleep versus test score. Now, how do we make it an experiment? If we simply ask students how much sleep they got and what their test score was, that's an observational study. How do we turn that into an experiment? Turn it into an experiment by imposing or telling students how much sleep to get. We specify you're going to sleep for this many hours, or you're going to go to bed for this many hours and see how much sleep and see what test scores they get afterward. So our experimental units then are the students in the experiment, however many students that we have. And then our treatments might be, we can kind of pick, right? This is going to be part of the way we think about an experiment, is we might specify, okay, what hours do we want to measure? Now, there's a lot of different answers you can do this. So I thought maybe we do something like 4, 6, 8, 10 hours of sleep. And we see if there's a difference between the group that was supposed to get 4 hours of sleep and 6 and 8 and 10. Did they do differently on the test? So those are our fundamental vocab. On the back, we'll talk about some pieces anytime we want to design a good experiment. So some of these terms should be familiar to us, such as a control group. As much as possible, we want a control group to provide a baseline for comparison. They might be given an inactive treatment or an active treatment, depending on the experiment. So, for example, it's hard to give a control group in sleep, but we just have lots of comparison groups. There's nothing like a normal amount of sleep. We just have different hours of sleep. But if we're doing a medication, someone can get a placebo, someone can get no medication, no diet, no exercise, something that we can compare to. And then when we say placebo, we mean some inactive treatment, like a sugar pill, something like that. And the reason that's important is that subjects will respond favorably to an inactive treatment as long as they believe it's real. So if we give someone something and say, this is a anti-inflammatory, a pain medication, something like that, a lot of patients will start to feel better even if it's nothing at all. So that means even if people are not receiving a treatment, they need to get a placebo so that we make sure that our treatment does better than simply giving someone a placebo. And this ties into our next two definitions. We want our subjects to be blind to which group they are in. It's an experiment. We're telling them what group they're in, whether they're in the treatment group or the placebo group. Single blind, if we kind of go out of order here, would mean that one of the two groups doesn't know which treatment they get. Double blind is when neither the subjects nor those that interact with them know which treatment the subject received. Sometimes we can't make something double blind. Double blind is the best way of running an experiment, but it's not always possible. If it's not possible, then we try to single blind. And it all comes down to the way that we've designed it. If we have a single blind, if we have an experiment, an exercise routine, people know whether they're getting the exercise routine or not. There's no way to hide that. But if it's a medication, by use of a sugar pill or an IV with nothing but water in it, things like that, you can hide from the patient what group they're in. And likewise, we don't know whatever doctor, nurse, whoever's interacting with them, we don't want them to know what group they're in either, so that there's no bias that we can introduce here. Because if there's any problems, if we don't have a control group, if we don't control for the placebo effect, things like that, then we might have issues. And our word for issues in experiments is confounding. Confounding is when we cannot determine what caused a particular effect. This is going to happen all the time in observational studies, but our hope is in an experiment that this does not occur. So an experiment, the well-designed experiment, is trying to avoid confounding, which is when we confuse, we cannot tell what caused a particular effect. And so that's what we're looking for here. So those are the basics. We're going to do this example below later as a way of piecing together all of these vocab words that we have when we're designing an experiment.